So in question 1, so this test is all about counting, and it relates back to, in this case, just putting an order on 6 people with regards to giving a presentation. So question part 1A, how many ways can the order of presentations be set? Well, if you have 6 people, so order certainly does matter. So you would have, so let's say 1, 2, 3, 4, 5, and 6. And now in order to be rearranging this, you may remember, okay, so if you have 6 people, so in the first spot, okay, you have 6 choices basically to pick from. And then you have 5 remaining people, so you have 5 remaining choices. In the second spot, 4 remaining choices, 3 remaining choices, 2 remaining choices, and then only 1 at the end. And if you want to know how many different orders there are, well, we use the multiplicative kind of principle or property, so we're going to be multiplying these through. So we would have this, and as you know, so this is nothing else but simply 6 factorial. So we can get that answer, okay, to this, okay, by applying it through, so 6 factorial, or just doing it directly, so that would have been 720. So there are 720 different ways that you can order 6 individuals to give a presentation, which is pretty crazy, but that's what it is. So that's part A. Now it gets a little bit different as we continue on with these different parts. So part B, how many ways can the order of presentations be set? Let's say if Joe must be third. Okay, well, in that particular case, so if we have, I'm going to copy this. Let's duplicate it, bring it down. Well, that's not what I wanted. Okay, so let's copy this. Let's duplicate it, bring it down. Now this will change because in the third spot, we are fixing. So Joe is going to be on the third spot, which means that we no longer have 6 people to try to order if Joe is going to be stuck at third. So that means that leaves us 5 people. So that means we're going to have 5 multiplied by 4. Okay, and then 3, 2, and 1. So really this is nothing else but simply 5 factorial. Okay, and this would have been 120 in terms of the number that we would have. So as soon as you fix somebody at a particular spot, that only leaves you and allows you to try to order the other spots. So that would have been the answer to part B. Now for part C, how many ways can the order of presentations be set if Joe is third, Jane is last? Okay, so in that case, so once again, if I take this, I'll duplicate it. So if Joe and then Jane, okay, so this is Joe and Jane, well, that now only leaves 4 other people to choose from. So 4, 3, then 2, and 1. So this would have been 4 factorial, right? So 4 factorial, so I guess that's 24. 4 times 3 is 12. 12 times 2 is 24. So that's the number of ways. So as soon as you start fixing some of the orders, it certainly does reduce, okay, what you have in there. Now the last one, part D, is probably the hardest. So how many ways can the order of presentations be set if Joe and Jane are together? Okay, so they must be together, which doesn't mean that they're together in a particular spot. They just must be side by side. Okay, so what we have is, in this case, so Joe and Jane are together. So this is, let's say, Joe, okay, and Jane. So they're fixed together. Now there are really 2 factorial ways to swap them, right? Because you can have Joe and Jane together, and then you can have Jane and Joe. All right, so from here, there's 2 factorial ways of swapping them, which is just 2. And now all the other individuals, basically we can order as you like. So what happens here is that if Joe and Jane are together, and we have, so if I take this once again and I duplicate it, and I put them as so, let's maybe change the color. Okay, so if we have that, and what that means is we have Joe and Jane, so they can be anywhere. So I'm going to just put, let's say Joe, Jane, so they can be like this. They're together. They certainly can be here. They can also be, right here, right? So they can be in the second, third spot, and so on. And you can arrange them anywhere you like, okay? But they're really just clumped together, okay? And there's two ways because we can swap them. So this is interesting because now what we have is really they're just adding or they're acting as one unit. So whenever you are told that something is together, that they have to be clumped together, then what you want to find out is, okay, if they're clumped together, then how many different ways can I arrange them? Well, I can arrange them in two different ways when they're together. So Joe, Jane, Jane, Joe. If there are three things clumped in together, right, that would have been 3 factorial ways that you can arrange those 3. But then they're going to be stuck together. So they act as one particular unit, which means now, so we had 6 people, but 2 of those people are together. So we really have just 5 items in total, right? One of those items is that clump of togetherness, all right? So that means we have 5 factorial ways of now rearranging, okay, the 4 individuals that are alone, and then this clump that comes together. Plus that clump can be swapped, right? So it can be 2 factorial ways. So Joe, Jane, Jane, Joe. So this is going to be, so the answer is 2 factorial multiplied by 5 factorial, or simply just 2. Either Joe is first or Jane is first, and then multiplied by 5 factorial ways that you can rearrange now, okay, all of the different items. So this would have been, I guess, well, 5 factorial is 120 times 2, so that would have been 240 ways. So that's part D. All right, and that completes this particular example.